Okay, so today we're going to learn how to use properties of parallelograms. First, we're going to learn them, and then the last three examples, we're going to be applying those properties. So first of all, we're going to define what a parallelogram is. So a parallelogram is a quadrilateral with two pairs of parallel sides. Now, just like before, when we did the chapters on triangles, remember, we didn't have to write out the word triangle. We could draw the little picture of a triangle and then put the letters for the vertices. I can do the same thing for a parallelogram. Instead of writing out this long word, I could draw the little picture of like a slanted rectangle and then put the capital letters for the four vertices. Now, they're writing theirs in alphabetical order. Technically, it doesn't matter what letter you start with, but you do need to go in order around the sides of the parallelogram. And what I mean by that is this same parallelogram that they're calling ABCD, I could also start with, say, letter B and call this BCDA. So go from here to here to here, or I could go in reverse. I could call it B, A, D, C. Either way, or you could start with the letter C and just make sure you go in order around the sides of the parallelogram. So by definition, it is a quadrilateral, so a four-sided figure with two pairs of parallel sides. So notice here, they've color-coded it. So the two red sides, AB, is parallel to CD, and then BC, the blue one, is parallel to DA. So you need two pairs of parallel sides in order to form a parallelogram. Here is our first theorem, or our first property of parallelograms. So these are all properties. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So the definition told us the opposite sides are parallel. Now this theorem says that those opposite sides are also congruent. So again, they've color-coded it. So in red, you have AB, which is parallel to CD, and it's also congruent by this theorem. And then the blue one, BC, is parallel to DA, and these are also congruent. Two more theorems, 8.4 and 8.5. Again, the number isn't important, but what it says is, so if a quadrilateral is a parallelogram, then its opposite angles are congruent. And again, they've color-coded it. So, for example, angle A, which is in red, the angle that's opposite to A is C, so A and C would be congruent. Angle B and the angle across from angle B is angle D, and those are congruent. The other theorem on this slide says if a quadrilateral is a parallelogram, then its consecutive angles are supplements. So here is where we're going to go back to first semester. And remember when we had parallel lines and we had alternate interior, alternate exterior, corresponding, same side interior, or consecutive interior angles. We're going to be using that for these quadrilaterals. So again, remember, another name for consecutive is same side interior. And what they mean by consecutive angles are the two angles that are next to each other, not opposite. So notice how A and B are next to each other. They're consecutive. If you were to go around the outside, A and B together are supplements. Notice they add and they're equal to 180. The other pair that's next to each other could be B and C. So when you add B plus C, they're supplements, they equal 180. We can keep going around. C plus D, because those are also consecutive, and they're also supplements. And then lastly, the A and the D down here, these are also supplements. So when you just go around the outside, the ones that are next to each other. Then the next slide has Theorem 8.6. This one states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Now, it doesn't state that the diagonals are congruent, just that they bisect each other. And what that means is this blue line, this piece is congruent to this piece. So BZ is congruent to DZ. And then for the red one, this piece, AZ, congruent to CZ. The diagonals bisect each other. They split them into congruent pieces. Let's look at the application now. So now, in order to answer these questions, I need to give you the information and state that this thing, ABCD, is a parallelogram. So ABCD is a parallelogram. So because it is a parallelogram, now I can answer these three questions. So it wants us to name all pairs of parallel lines. So again, remember by definition, a quadrilateral with two pairs of parallel sides is a parallelogram. So we can see that AB is parallel to CD. You could also name it, you could also say BA and CD. You can switch the letters on this. Okay, then the other pair is the one with the two arrows there, and you can say BC is parallel to AD. So this is the answer for number one.
Would we have to name like every single one?
Yes, but there's only two pairs here. You don't have to name.
You name BACD and then BC.
This is just a repeat of this one. I just wanted to show you could switch A and B.
Oh, okay, so there's only 4 total.
There's only two pairs.
Okay.
Does that make sense? Okay. Now, for the congruent angles, however, there's a bunch.
Yeah.
Okay? So, by our theorems we just learned, we learned that opposite angles in your parallelogram are congruent. Now, I can't just call this angle A and angle C because there's more going on here. So I need to name these angles with 3 letters. So for question number 2, I'm going to call this angle BAD, which is this one right here, is congruent to BCD. Then I have the other ones in the other corners, this one and this one. So we'll call that angle ABC is congruent to CDA. Now, those diagonals, when they bisected each other, they formed 4 angles there. So I have some vertical angles going on here in the middle. So I have this angle, which is congruent to this one. And again, I can't just say angle E. I need to name it with 3 letters. So I'm going to call this BEC.
Pardon interruption.
Okay, so I'm going to call this BEC is congruent to AED. Then I have the ones on the sides of that, the vertical angles here. So I can call this CED is congruent to BEA. Now, if you called that AEB or DEC, those are fine also. So we actually had 4 pairs of congruent angles. Now we need to name all the pairs of congruent segments. And there's a bunch here also. So we have the theorem we just learned that opposite sides in a parallelogram are congruent. So we could do the opposite sides. So we could say AB and CD or DC. And let's call this DC. And I can put segments on top of these guys too. Okay, then we can do the other pair of opposite sides, this one and this one. So BC is congruent to AD. And now we also have those diagonals that were bisected. So we can name those pairs. So we have this one, 2, 3, BE, congruent to DE. And then the other one, 1, 2, 3, 4, 1, 2, 3, 4. So I could say AE is congruent to CE. So those would be all of your congruent segments. The two pairs from the diagonals, and then the two pairs from the opposite outside edges of my parallelogram. All right, so notice they're telling me that RSTU is a parallelogram, and they want me to find X, Y, A, and B. So notice this one they forgot. So let's call this RSTU. We could add letters to that. But let's go ahead and do part A first. So let's take care of the easy ones first. What is B? How much is B? 9. Opposite sides are congruent. What about X? Good. Opposite angles are congruent. So this and this. Now, what's the relationship between the 80 and the Y? What kind of angles? Supplements. Good. So how much would Y be? Beautiful. Pretty good? All right. Let's try B. This one's a little more complicated. All right. How much is A? Good. All right. Now, just to clarify, this X that's up here, see the little degree symbol? They're referring to the angle, but they want the whole thing. Okay, that's what it's referring to. I know it's kind of confusing. Now, first of all, let's figure out how much this one is down here.
80.
Good. So this whole total down here is 80. So how much would that make X? Good. Now, how are we going to find Y?
It's just 80.
Well, Y's only referring to this side. Good. These are alternate interior angles. Let me show you the parallel lines. So I have parallel lines here. And then I have my transversal. So alternate interior, making it 45 degrees. So we're going to be bringing all of this back from first semester. One. We got a parallelogram here.
Wait, what? Did you do B?
I did B.
Oh, you did?
B. Beautiful. Those diagonals were bisected. So it's the same as this piece over here. All right, now let's go on to C. How are we going to find the value of X? Good. Opposite sides are congruent. So 4X equals 8. Divide by 4. And X equals 2. I'm going to do exactly the same thing for Y because opposite sides are congruent. So 3Y plus 4 equals 13. Subtract the 4. Divide by 3. And Y equals 3. They're telling me that we have a parallelogram, and it is PINE. So it doesn't matter how you draw it, just stay consistent, go around the edges. So I'll do a PINE. PI is 12, IN is 8. Remember, opposite sides are congruent. So this would be an 8, this would be a 12. It wants me to find perimeter. What do I have to do for perimeter? Beautiful. So 8 plus 8 plus 12 plus 12 gives me 40. Because I could do 16, 24, and I get 40. All right, so your homework is the A2 assignment. It's on Canvas. Go ahead and work on it. Tomorrow we'll learn 8.3, and then you'll have that quiz on Thursday. That's it.